getting serious.
Okay.
I just heard that word.
Then she is back. Okie dokie. Listen up for me. Listen up for me. Jeremiah. Thank you. Okay. If you take a look right here up at the board, I mentioned this like as I was walking around, but now that I've got everyone's attention, today and tomorrow, your due first is going to be on a separate sheet of paper like this, where I am choosing problems that I think will help you out with quiz and tests next week, reviewing old stuff we've learned that if you haven't like gone back and studied, I think some people could be forgetting. But you'll definitely see on assessments next week, so are really important. So, starting with this due first. Starting with this due first, I want you to take a look at that table of values and see if you can remember what we learned about even and odd to figure out whether f of x is even or odd. Hint might be, since these are like points, like x and y, you could start plotting them. You could draw your own sketch and start plotting them and see if that helps you to see whether it might be even or odd. If you're like, I don't even know what even or odd is, this is then an indication, like, I'd rather that happen now than when you're on the quiz, and so we can kind of figure it out, okay? I'm going to take attendance. You guys take a look. If all else fails, at least start plotting some of these points to see what the graph looks like, and we'll pick up there in a moment. Try it out. See if your neighbor remembers what even and odd is. Maybe they can help you, because they won't be able to on the quiz. Gio, Samuel.
This one is odd.
No Samuel today? Pedro. Leisha. Here. Johan.
Here.
Pedro. Kaylin. Carlos.
Here.
Catherine. Caitlin. Levy. She. Jason. Jeremiah. Still looking around and I don't see everyone plotting or working on this one. Emilio's table, get going. Cindy. Jennifer. Angela. Rhiannon. Michelle. Osi. Omar.
Here.
Christian. Diana. Samantha. Fatima. Natalie. Emilio. Javier. Edgar. Samantha. So, no need for a calculator either. You're just plotting, and then this would be on a non-calculator section. You're just plotting and figuring out what it looks like and whether it would be even or odd.
Oh yeah. So this is a negative.
I can't sit still.
How long do you have meditation?
So she's going sandstone, and then you can go, but then tomorrow I'm gonna stop again finish. Not necessarily, but like for some people that are like, I don't even know where to start, then they can see it visually. Because an f of negative x is equal to f of
Guys are doing great. Let's make sure more of it.
I know that we're going to take. Alright.
I'm playing, I don't know.
Boys, stop by back up here. Perfect, thank you. Yeah, sorry, those of you that finished and you flipped to the back and you were like, I don't know how to do this. On the back, that's what we're doing today in class, so that's gonna be, we're gonna leave actually with an exit ticket today that you're gonna turn in to me, and I'm gonna grade tonight your exit ticket to see like who's in a good spot with today's lesson and who needs more review. Because tomorrow we're gonna be kind of like doing the second part of today's lesson, and it'll give me some info about what we still need some help with, okay? Okay, so on the front only, right now we're only looking at the front. If this is our function, and every person in here, like if you were like, I'm lost, I don't know where to start, I told you to at least start plotting some of these points, like you should be able to draw like 0, 0, 1, 1, 1, negative 1, 1, all of these kind of like points you can start to label and get an idea. 2, 4, negative 2, 4. An idea of what's going on here, right? So like whenever you're stuck on a problem, I'm going to try to like also coach you this year on like when I'm stuck, like where do I even start, okay? So when you're stuck and you're like, the table, like this is kind of different than anything we've seen before, like you have the skills of what even and odd are, and if you study and you know what even and odd mean, then at least start by taking your table and maybe looking at it in a different way, like a graph, and maybe it'll like get you going, okay? So now that we have those points plotted, and we're seeing a little bit more what this could look like in some way, it might start to jog our memory about what even and odd like has to do with. So someone out there in the crowd, we learned even and odd. I got a poster I'm going to show you in a second. Does anyone remember what we're kind of describing when we're talking about even and odd? Angela?
Is it odd like it goes to the origin?
Something about the origin, not close to the origin, but it's origin symmetry.
Oh.
Okay, and then Omar?
Is it, how you know it's even or odd?
Mm-hmm.
You know it's even if f of negative x equals f of x.
Cool.
So if you see that on the line, if you go to the positive 2 x, on the x of positive 2, it's 4. And if you look at negative 2, so x, negative 2, f of x is 4 as well. So they're both even because they're
The
they
same,
both
you get
equal
the
the
same
And
output.
if it's odd, if it were negative 2, would it be negative 4, which means it's yeah.
Cool. So he's describing this definition right here, which says things that oh, he's not here. Sorry. No help. That an even, when we plug in a negative, we should get the same value as our positive x, which is what he's showing right here from the table he was able to see from the beginning, okay? Now let's say you're like less familiar with that definition. Angela mentioned something about origin symmetry. Does anyone remember what the other one was, Rhiannon?
If it's symmetrical across the y-axis.
Cool. So if it's got y-axis symmetry, that's even. And Angela said odd is origin. Odd, origin, even, y-axis. And so if you just look at the picture and see that this is reflected across the y, that could be another way to see that this is a even function. So you can use symmetry, you can use the definition with the negatives, and I'll basically show you then these things on my posters should be things that you're starting to like commit to your memory to be successful on quizzes and tests. So notice I have odd, the definition, and even the definition he talked about, and then also the symmetry like you guys were talking about, okay? I even had like Yabron last year was like on it, and after school he would come and he'd be like, hey, can I like take a few quick pictures of your posters? And he like loved to take pictures because he just wanted to study these and like have things. So you're welcome to do that at any point if you feel like that's something that helps you. If not, no worries. But if you like the posters, you can take a picture of them. But regardless, hopefully that do first is kind of a way to like do a gut check of like, did I look up at this problem and was like, I don't even know. Because if that's how you were feeling, that's okay, because today was just to do first. But know that all those things we've been talking about, that maybe you did well on the practice like that day, if we haven't revisited them by practicing on our problem sets and things like that, then they might not be there. Don't expect them to be there Monday or Wednesday next week when you're being assessed. And because this, the weeks we lost, you just don't have as many grades in the grade book. So there won't be a lot of time to make up for your grades next week if they're not where you're at, because A1 ends on Friday. Okay? Okay. So, that's even and odd. Cool. Just kind of mentioned this, but problem set 3 is due on Wednesday, but like I said yesterday, your quiz is Monday, and then we're reviewing Tuesday, and then your unit exam is Wednesday. So lots of assessments coming your way. So you'll hear me start to talk a lot about like reviewing and studying, like you've already heard me preaching to you and do first. Tomorrow, I'm gonna try, before unit exams, I always give out a like study guide that almost is like a one sheet that has all of kind of this stuff and some other stuff summarized versus flipping through your whole notes packet, okay? That hopefully can help you to memorize the things you need to memorize and refresh on what is even on the test. But since your quiz is actually kind of like a mini unit exam, and it's going to cover everything we've learned because we have pushed it back now till next week, I'm going to try my best to get everything printed and ready to go to give that to you tomorrow, so you have it over the weekend to study, okay? So keep a lookout for that. Yep.
So the unit test is gonna be over what's on problem set 1, 2, and 3?
Mm-hmm.
Okay.
1, 2, and 3, and of problem set 1, remember that we did a few things like the first few days of class that were more review of algebra that will be like less on the test explicitly. Those were more skills we just wanted to like be able to have to use. But starting like, you know, day 3 or 4 or whatever, we jumped into more of the like pre-cal stuff that's going to be on the unit exam.
So everything we're gonna need to know on the exam is gonna be done by tomorrow, or is this today?
Yes, honestly, you'll have all the information today, and then, but because this lesson, I just feel like I want to practice a lot with it, I'm like extending it through tomorrow for more practice.
Okay.
Cool? But like as of tonight, you could finish your problem set 3 and like just be studying
Bring it tomorrow.
and ask me questions and all that.
Okay.
Tomorrow during lunch, I'm available. Today, I'll be here after school. If you need me to come early tomorrow morning, I'll come early. Same thing Monday. Get you ready. Cool? Doesn't open until 6:45, but I'll be here at 6:45 if you need me to. Yep.
So, wait, so what time are you saying?
Tonight, I will be here, like, I can stay till like 6 or so, but if it's like 5 o'clock and it's been an hour and I'm like done with my work and no one's here, it's like crickets, then I'll probably leave because I'll assume no one's coming. So if you like leave school and come back, then let me know you're coming back later. But if there's people here and that we're still working, I'll stay. Kind of indefinitely, not really, but 6. Below that. Okay, cool. Hopefully that answers all your questions. Thanks, Omar. Today, last topic of the unit, woo, we made it. We learned a lot, is inverse functions, and this is going to be found on page 41. Sorry, since our do first wasn't in your packet, I didn't have the page number up there, but I'll give you a second to turn for me to page 41. And set a goal for yourself. I know we're kind of tired. Even this morning, I wasn't feeling so good. I had to have some emergency in my system. I had a big glass of water because I wasn't feeling so good. Now I'm feeling better. But I need y'all to kind of push through, especially because, like I just mentioned, we've covered so much material. Like, make your study time for inverse functions be today and tomorrow in class, and like work really hard on the practice so that you don't have to put in extra time studying those and you can go back and like review the old stuff, okay? So stick with me today, have it like soak in, and make sure you don't have to like follow up and rewatch the video later. So, inverse functions. Raise your hand if you feel like you've heard this word or both these words before. Inverse functions, anyone feel familiar? Okay, hands down. Maybe if you haven't seen inverse functions, you've heard this word inverse, like we say inverse operations. When I'm talking about inverse operations, like what's the inverse operation of addition? Subtraction. They're like opposites and they undo each other, right? So inverse, oh, we wanted in, sorry, I just waved at you. I thought you were just saying hi. Inverse functions, similar to inverse operations, stick with me, he's wonderful, but eyes over here. Inverse functions are functions that are kind of, in a way, like opposites, or they like undo each other, kind of like addition and subtraction, okay? So let's take a look right here. This first part of your notes, this whole page right here on page 41, is basically like a big long definition of everything inverse functions that you'll need to know. But it's kind of overwhelming, so we're going to break it up kind of like piece by piece to make sure we understand what an inverse function is and how we know if a function has an inverse. So, can I get someone to read for me right here, inverse relations, and everyone else do whatever you can to turn on your brain and make sure you're soaking it up as we read. OC, go for it.
If a function contains a point x and y, the inverse relation contains y, x. When a relation is expressed as an equation, its inverse relation can be found by interchanging the independent x and dependent y variables.
Okay, so again, inverse, we said is kind of like opposite, or they undo each other. So an inverse relation is when something contains a point like x, y. One equation has x, y. One way to think about it is its inverse relation would be if we switched those and we had what? Yx. Okay, so kind of key like idea to keep in mind as we go through today is we are going to be kind of like switching x and y, so that if we had x, y before, now we have yx. So it says we're interchanging the independent and the dependent in our equation, in our graph, in whatever way we're looking at a relation. Okay, so let's look at graphs first. Let's take a look at what I mean. Two beautiful graphs. Everyone take a look, admire the graphs. They're so beautiful. Okay, if you look at this first equation, or this first graph, this purple one, I think it's purple one. Notice this point right here is negative 4, 0. If I interchange or switch x and y, negative 4, 0 would now be what?
0, negative.
0, negative 4. See that point right here? I plotted it for that new graph. Okay, let's try another one. Negative 3, 1. If I interchange x and y, what do I have?
1, negative.
1, negative 3. There it is, right here. So if I were to take every single point and switch them, I would get all of these points that make that green graph right there. Therefore, these are inversely related. This graph and this graph are inverse, have an inverse relation. Okay? And notice the graph itself is reflected, like we've talked about reflections, but not across the x-axis or the y-axis. It's actually reflected across this diagonal line y equals x. Okay? So graphically, that ends up happening. Okay, let's look at example 2. Take a look. I've got this pretty pink parabola, and let me pick like this point right here looks like 2, 5. So the inverse relation should have, let's try it, 5, 2. Hey, look, there's that point over there reflected across y equals x. Okay, so that is graphically kind of one way to look at an inverse relation. Keep that in your mind, like switching x and switching y. Okay, I've been saying over and over, if you were listening carefully to my language, I've been calling it an inverse relation. And what did you notice we were going to talk about today? Inverse function. So now I'm going to kind of like in this second paragraph bring these two together and talk about how we know not only is it inverse relation, but is it an inverse function, keeping in mind what it has to be true about it being a function. Okay? So let's think about functions. Let's pick up right here where it says remember. Can I get someone to read right here where it says remember? Rhiannon, nice and loud. Everyone else soak it up. Here we go.
Remember, in order to be a function, there must be one y for every x. So in order for the inverse to be considered an inverse function, there must also be one x for every y. Therefore, functions that have an inverse function are what we call blank blank.
1-to-1. Okay, so again, paragraph 1, I don't know what all that means. So let's break it down, okay? First sentence, remember, in order to be a function, we talked about that like back at the beginning of the unit, there must be one y for every x. Raise your hand if you can tell me, we like talked about a test to figure out if something was a function. How do we remember if there's one y for every x? Carlos?
Is this the vertical line test?
The vertical line test, right? So if you have something that looks like this, as long as everywhere I draw a vertical line, it only passes through one spot, then it's a function, right? Okay. If that is true for a function, in order for the inverse, stick with me, in order for the inverse, this second graph, the green graphs, to be a function as well, they must also have, like, pass the vertical line test, which means from the beginning, there had to be one x for every y as well, okay? Notice for this one, this passes the vertical line test, the purple graph, right? And then the green one, as a separate graph, also, like, passes the vertical line test, right? So this is not only, this is a function, and then the inverse relation is also a function, so it's an inverse function. Over here, Gio says it doesn't. What do you notice about the inverse, Gio? Not function. So it's an inverse, like, relation, like x and y still switched, but this graph, we cannot call it a function because it doesn't pass the vertical line test, right? So it is not an inverse function. These are just, like, related to each other, like, inversely, okay? So this, we would say, the purple graph has an inverse function. This one, we would say this pink graph does not have an inverse function. Let's see.
Does it have to be intersecting to be called an inverse function? It's basically switched apart.
When you, oh gotcha, like these intersect right here? Not necessarily. So that's not going to be our test, but that's a good observation that this one does and that one doesn't, right? But, so what we are going to test, like, I like that you're looking for something, like, how can we figure it out, right? If we were to look at this original graph, okay, bring it back, like, you're like, oh, I fell asleep, but okay, bring it back, very important. This original graph right here was a function, but notice when I reflect it across the y equals x line, now that became like a vertical line, right? You agree? Therefore, the way that we can check, the test that we can do to make sure something is what we call one-to-one, or like doesn't have the issue of like when we rotate it, or not rotate it, reflect it, having that two intersecting points, is we can do another test, very similar, but not a vertical line test. What is it? A horizontal line test. What is it? Pedro? Oh man, he's with me. Horizontal, I love it. Horizontal line test. He's like, I'm soaking it up with my eyes closed. Okay, so what we're going to do is not just like the vertical line test to make sure it's a function, but we are now, welcome to the world of inverse functions, we are going to do a horizontal line test to make sure it has an inverse function. Cool? Okay, let's see. I lost my clicker. Let's see if things have inverse functions. If it does, sorry, I know this is a lot of text right here. It's kind of like text heavy. If it does have an inverse, yes, question?
How do you do the horizontal test again? Like,
Whoa, I'm gonna get there. Okay. Yeah. If it does have an inverse, let's say you do the horizontal line test, which we're gonna look at. If it does have an inverse, just side note, some of y'all might have seen this before. You use like this little -1 little kind of subscript thing and say f to the -1, but we read it as f inverse of x. That's what we call that new function. So if the first one was f of x, this new one is f inverse of x. Okay? And we can do the horizontal line test to see whether it is one-to-one and whether it's going to have an inverse function. So Omar's question is, how do I do the horizontal line test? Let's say this blue line is my function, f of x, and I want to know, can I find an inverse function? I need to make sure that it's going to be one-to-one or like not run into any issues. So you just like similar to like we do with a vertical line, picture a horizontal line anywhere on this graph. It's only going to pass through one point, right? If it like looped around and passed through two, it would not pass. But in this case, we pass, okay? Let's make sure we're really good at just passing the test. So I'm just going to show you like 5 graphs right now. We're just going to say yes or no. Cool? Let's just like rapid fire, figure out if we like horizontal line test, and before we move on to actually finding the inverse. Okay, so I'm gonna go to popsicle sticks to keep everyone on their toes. So it could be any of you from the crowd. I'm gonna show you a graph. All you're doing is picturing a horizontal line and seeing, yes, it passes through only one point, or no, it fails because it passes through more than one. First one. Johan, lucky winner. If this is our graph, would it pass, Johan, would it pass the horizontal line test?
No.
No. Take a look. See my I'm using his own popsicle stick. It passes through multiple, even 3 spots, right? Yes. One. Only one. Because we wanted to have one x for every y now, as well as one y for every x. If I said that right. Vertical, they're both 1 point. But now we're just going from vertical, we're going to horizontal to make sure that when it's reflected, that it passes the vertical and it's a function. Okay? Okay, next one. I'm going with Sam. Okay. Emilio, take a look. Does it pass the horizontal line test? Yes. No matter where I pick, I'm only going through one spot. Cool? Okay, we're getting better at this. The more you see, the better you feel. So, turn your voices off. Next one, Jennifer, over to you. Take a look. Just as a side note, this might look like it's flattening up, but it's still decreasing. It's just like slowly decreasing. Yes or no? What do you think?
Yes.
Yes, it passes. Even if, like, I know here it looks like it's gonna like go through multiple, but it's still decreasing just slowly, so it's hard to tell, but you could zoom in and you can see. Okay.
Except for right too.
Kaylin with an E. Last one. Yes or no? No. See, it's passing through too. Okay? Okay. So the first thing that you do when you approach a function and they ask, find the inverse function, is you got to see whether there even is one, because there's a possibility that there's not. Okay? So we always are just going to do the horizontal line test first to see if it's 1 to 1. Then if we're good, we'll start finding our function. Okay? So flip to the top of the next page independently for me. Just like we just did on the board, I want you now, in case I didn't call on you, to make sure you know what to do. There's 2 more problems where all I want you to do is tell me yes, there's an inverse function, or no, there's not, using the horizontal line test to see if it's 1 to 1. Okay, independently, just write your own answers, and we're going to check them.
Oh, yeah. Let's do, I'll probably need part of the rough, like the first situation and stuff,
Got it? No. Okay, let's take a look. First one, who's got it? I'm into all those people those 5 people I picked on, I'm going to bring you a stamp.
Oh, yeah.
But, 2 volunteers. Everyone else, bring it back. Me. Carlos. Yes or no?
No.
No. And so one more time, I'm gonna kind of pick on you to push it a little bit more, just so that we know we're not just drawing a horizontal line. No. What does that mean again? The fact that it doesn't pass the horizontal line test. Can you remind me what that means?
It means that there's no inverse function.
Good. Not an inverse function. And I like the language you used in the last class. Someone said something really close but not quite right. They said, this is not an inverse function. And I was like, this, I agree, is not an inverse function, but not because of the horizontal line test. We're seeing if there's going to be, remember there was a graph and another graph? We're seeing if it's possible to get an inverse function. So he said there's not going to exist an inverse function for this graph. Okay? This is just a function. Cool. Okay, and next one, Carlos, call the next person.
Angela.
Angela.
It is an inverse function.
This thing is?
Yeah. No. Wait, I'm thinking.
I agree with yes, but let's one more time. What does this mean? It doesn't mean that this
Oh, that
graph
is-
is an inverse
that is-
function. It means what?
That is, it means there's a horizontal. And
It
there's
passed
a
the horizontal line test, okay? And you're close. You're super close. I'm just like picking on like little words here. So listen up, Angela. Catherine, what does it mean?
That there will be an inverse function.
There will be an inverse function, like there does exist an inverse function that we're about to go find. This graph is not it, but we will find one, okay? So I'm gonna write, everyone write this so that we make sure we know what we mean. Yes, there is an inverse function that we can go find. This is not it, but like we're gonna find it, okay? Cool, we got it. We love the horizontal line test. Brandon. Edgar.
I have learned.
Good, keep learning. Okay. Next up, finding the inverse of a function. So now we know whether there's one or not, like I said. So we're going to move forward in the rest of class. We're going to talk about, okay, so now that we know if there's one, how do we find it? Okay? Here we go. Determine whether f has an inverse function. If it does, good, we know how to do that. If it does, find the inverse function and state any restrictions on the domain. Okay, here we go. Here is our function. Because we got quizzes and texts next week, I'm rolling in some review. So this function, I did not give you the graph of because we should be able to graph it by hand, no calculator, by hand using, no, by hand using our foldable, our parent functions, and transformations. Who can tell me, you don't have to like discuss anything, but who can tell me, who can raise, sorry I should have said raise their hand and tell me, what is our parent function that we're just like moving around and doing stuff to, Kaylin?
It will be the root of x.
Cool, which looks like this, you need to commit to memory that it looks like this so that you can sketch things like this without your calculator. If I take this graph and I subtract 4 on the inside, raise your hand if you can tell me where the graph is going to like move or what it's going to do. Catherine? Side to side. Cool, someone help her out. Which side? Geo? To the right. It's the opposite of what you'd think. To the right, 1, 2, 3, 4. It's gonna look like that. Okay? Okay. I know lots of people stamps. I need you like to raise your hand only if only if you were one of those people from earlier that I got. As I'm gonna keep talking to save us some time, okay? Alright. So Pedro, I'll come back to you in a second. I just gotta keep talking. So, looking at that graph now as I walk around, same skill we just learned, does it pass? Raise your hand, does it pass? Okay, I'm gonna stop. I want to be able to give out stamps, but if I can't walk around the room and give out stamps while everyone stays quiet, like I shouldn't have to stand up there for us to stay quiet. So I'm walking, but our voices are still off. Raise your hand if you can tell me whether this is 1-to-1 using the horizontal line test, so we can keep moving and we don't run out of time like yesterday. I think we ran out of time, Alicia.
Wait, you're asking if it passes? Yes.
Yes, it does pass like we just did. Anywhere you draw a horizontal line, it'll pass through 1 point, not more than 1. Okay? So we would say yes, which is why I'm using this as our example, because now that means we have to go find it. So in the last few examples, we just said yes, and we like moved on to the next problem. If we say yes, we need to actually find the inverse function, and that's what we're going to talk about now. Gio? Gotcha, like the points you're saying? Like this is 4, 0, it would now be 0, 4. Cool. So we could start plotting points and like drawing it, love it. but I want actually the equation of the function. So we're going to learn algebraically how to find the equation of the function. So if I have f of x equals the square root of x minus 4, I'm going to show you how to do this. First off, let's come back to the very beginning. Remember we said that if I have x and y, I now have y and x. So what we're going to start by doing is, if this is really kind of like y equals square root of x minus 4, I'm going to exchange the variables and replace x with y and y with x. So I'm going to do this. I'm going to say x equals square root of y minus 4. I'm going to switch up. Switch x and y. Cool? Okay. Next up, I'm going to use legal algebra moves, which now I'm going to like move some things around with algebra to solve for y to get my new equation, y equals something. Okay, so if I have, I'm going to just recopy it so that I'll have it. Gio says to undo this square root. I heard him say quietly that we can square both sides. Do you agree? Okay, so we have x squared equals, and now our square root will go away and we'll just have y minus 4. We're getting closer. We just want y. Pedro, what do we do now? Add 4, x squared plus 4 equals y. We have solved for y, and we now have a new equation. Because of all the work we did in the beginning, we know that this new equation is actually a function, right? That's why we did the horizontal line test, so that we know that when we reflect it across y equals x, it's going to pass the vertical line test. So this is a function. Therefore, you'll see in step 4, keep going, step 4 says, congratulations, you found the inverse. Now, just rename it as f inverse instead of y, and we found that that was x squared plus 4. I am going to be very picky about, you might have done all the hard work, yay, good you found the equation, but if you leave it like this, you're not going to get full credit because you did not acknowledge that what we solved for is the inverse. You have to rename it as f inverse. That's like a nitpicky kind of like thing for me to take off credit for, but it's building like good math notation skills that you need like in calculus and stuff, okay? So rename it as f inverse, and you have your inverse. Congratulations, you're there. Now, if you go back, thank you for sticking with me, and this is kind of like a long example. If you go back and read the directions from above, it said to find the inverse and state any domain restrictions, which means our last step we see here in our notes is that we need to state any restrictions on the domain of our inverse. All right, now you're like, oh, domain. No. Domain is your x's. So the cool thing is that if our domain is our x's, remember this is f, this is f inverse, right? Because we switched x and y. If our domain, watch me, if our domain is our x's, those are actually our old y's. So our domain is actually the range of our like original function. Okay, let me say it one more time. When we take the inverse, because x and y switch, Jeremiah, because x and y switch, our domain and our range actually switch, right? Therefore, the domain, we can find it by just thinking about the range of our graph that we had before, right? So let's think of that graph. I'm going to read, mine went away, but this was over here, okay? And this is at 0. Let's think about the range of this graph will be the domain of this graph. If I start from the bottom, when Caitlin is the first time, I'm going to hit a y value that we have. 0, and I have a point there, so it's a bracket. And then all the points above, like we've got graph. So 0 to infinity. is our range of our function. So when we switched x and y, it is now the domain of our inverse function.
Uh-huh, I thought you did switch it.
So I'm gonna pick on just a few people, and again, if you don't have it yet, that's okay, but I'm gonna pick on people and make you kind of like revoice what I just said. Diana, I'm coming to you first. Diana, can you tell me how we can find the domain of our inverse function? What can we use? Nice. Can someone else repeat really quick, like what she said, a little louder? Because that was soft. Jeremiah?
To find the domain of the other function, you can use the range of your original function.
The range of your original function, okay? And then call it the domain of this new function, because x and y have changed, okay? All right, awesome. So, we have learned, oh, what is the range? It doesn't ask for that. You have to state any restrictions on the domain. Actually, I like this. Okay, so I know I'm talking a lot, but this is cool. Caitlin asked a good question. Listen up. Caitlin says, like, what about the range? So the reason, if you're curious of like why we're doing this in the first place, is let's go ahead and graph what we got. Hey, look, another parent function. Natalie, take a look at your foldable because I see it's out right there. What parent function is this coming from? Everyone else. The quadratic. And if I added 4, anyone now, raise your hand. If I added 4 on the outside, what did I do to the quadratic? OC?
Go to
It's on the outside, so up and down. Which one? Up 4. But look at it, y'all. If it's a quadratic, it has like 2 sides, right? Like it's like a parabola. And notice from our pictures earlier, now they don't look like a reflection. It doesn't look like a reflection. I had to restrict my domain to what my old range was, right? Because to show that it's the reflection and we don't have those like extra points that we have in that equation. Okay, so we only want from 0 to infinity for the domain of this new function. That's the domain, right? Starts at 0 to infinity. Yep.
So does that mean that's an inverse relation?
This is an inverse relation and this is the inverse function. This is f inverse of x and this is f of x, which we started with. Wonderful. Stamps all around. He's like, okay. So not only can you just find it as the range, but like technically if you wanted to graph it and just look at the domain, you could do it that way. Okay? The reason we got those extra points is when we squared both sides, we basically like were re-allowing the negatives into play, when in our original square root function, we can't take the square root of negatives, and so we like didn't want those values. So, interesting stuff going on here. Okay. With that being said, I'm going to have you, tomorrow's going to be like practice of this. But for right now, what I'm going to have you do is take the back of your do first. I want you to practice this on the exit ticket on the back of your do first. And you are going to turn this into me so that when we pick up tomorrow with the rest of the problems for practice, I can kind of already know who to maybe check in with that might need help on some of this stuff, okay? So on the back of your do first, try this one out so we can see where we're at. We'll do this tomorrow. Tomorrow right next time. So graph it, see if there's an inverse. If there is, go ahead and find it algebraically. You can look at the steps, but remember we're switching x and y and then trying to solve for y. So is it pass? Yep, so now switch your x and y and solve. Technically yes, but what I'm going to give you, if I'm calling it f of x,
like I gave you f of x, I'm already calling it a function, it already passed the vertical line test. So all the things I give to you should pass the vertical. And then what we're checking is like, okay, now since we're gonna be changing it, we gotta make sure when we change it, it's still gonna be a function, so we have to do the horizontal. Cool? So this f of x always basically is just another way to say y, but it's like calling it a function. So we just are really calling this y, so that we can replace those two things. And then at the end, we'll replace it with f inverse. Okay, so you just took, I just rewrote this with a y here, so I can show that we have y equals this, and then we switched it because we're finding the inverse.
I have a question.
Why did I start at 0? As in, why is there a bracket, or just in general, why is it 0? Okay, so if you look at your original function right here, we're looking at the range of this function, because then we flipped everything and then we did the basic order. So we think of a range starting down here, negative 5, negative 4, like there's no points down here. So none of these are included. The first time we have a point is here at 0. And we have that point, it's not like an open circle, so we put a bracket, and then we have all these numbers up here. So we can put like this.
Do I have to like graph this?
No, I didn't, I mean, they might ask for it, but I just want the inverse function, and then I want any domain restrictions. So finding the range of the one. Okay, so we're thinking about the range of the domain. Let me look at your picture. The range of this one, then it'll be the domain of this.
That's right.
This is a range of the domain. We just shifted it. Your range
So you find the
but it's still
You find the range of this, but it doesn't range.
Do we have to find the range?
So in terms of our domain,
See, I'm saying just call this, give me a headache, just put a D, but you have to find it, like, oh my god. Then it's the same equation.
domain and range, that's hard, but this is
Yeah, this is.
Alright, I think for the range of that, which is the domain of our new function, because they switch. Okay. Okay. I'm gonna bring back because some people are chatting, which means I think we are for the most part done. So to save me some time actually, I'm gonna have us kind of just like check it and grade it in here. But I want to urge you, this is not a grade, and like you don't need to be embarrassed about whether I see whether you did it or not. So this is not like, oh, now I write down the right answer. This is like grab a pen or switch with your neighbor or something, and we're going to check it so that we can see, given that amount of time, how we did. Okay, so grab it.
it looks the same.
This problem was very similar to the one we did, right? So we should have felt fairly comfortable. I'm gonna wait, I wanna let you out on time, but I need voices off so I can not just talk over you. Okay. Really quick, I'm gonna run through, like, just final answer, not run through everything. F inverse, you're looking for this exactly on the paper. F inverse equals, actually, what should I hit? X squared minus 3. But, stop. Edgar, pause. We're looking for it to have this notation, no longer y. They had to change it back to F inverse. And algebraically, they need to solve the right thing. And they needed the correct domain, which should be bracket 0, comma, infinity. And I don't want you to think that this is going to be the domain always, because that happened to be what it was the last 2 times, because they were both like very similar. So tomorrow we'll see lots of other examples where we start mixing things up, okay? Okay, take one pile of these at your table, and you can go ahead and pack up for me, and when the bell rings, head on your way. Stamps, come in.
Hello, Dave.
Right here.
Yes, perfect.
Jeremiah, here, stand this,
Dang, Fatima, you yeah, you are.
I like that.
Glad you're going to. Oh, yeah, it's good. It's good.
For this one, you don't have a number in here. So you're taking g of x, this entire thing, and plugging it into this. This whole thing squared minus 16. Let's talk tomorrow.
We'll play Overwatch and go this
I should go to bed. What are you doing there?